And also, by the way, I emailed you all with, Lucas, I emailed everyone with the link to all the recorded session. If you click on the link, you see all the recorded session from the beginning all the way to the last session. Then I have sent you the link, and I'm just also recording this session. And now let's get started. Now, today we are only dealing with one very important problem. We have learned all the techniques that we need to know how to solve this, but today is going to be more like a practice, but this practice comes with a very subtle trick. Very subtle trick. I hope everyone listens. You know all the tools, but there is a little subtle trick. Now, what is this? We are going to solve this problem. And by the end of it, then you're able to just go back to solve the thing that you have. Yes, Kate?
So now, after this, you're going to be able to work by yourself on a problem?
This one?
After we finish this?
That's right. Because you need to know this knowledge to just be able to work on the one that I'm just going to give that to you today. And I call it, huh? Yes. Then when you just go back to work on it, so that thing is going to be very easy. Now, guys, look at this. We have two persons here, Daniel, Albert, and Bell, that they are doing some kind of scientific research. They are just gonna, I should say, launch a balloon. And that's what they want to do. They are just gonna launch a balloon. Albert has a rope which is attached to, I should say, to the balloon. And the length of the rope is how much? 7.8 meters. And also at the same time, Bell is doing the same thing, but the Bell's rope attached to the balloon, its length is 5.9 meters. And also remember that for the case of the Albert, it has an angle of 36 degrees with respect to the ground. For example, if this is, for example, Albert, the balloon is there, for example, and that's the rope. The length of the rope from my hand to the balloon is how much? 7.8 meters. And the angle with respect to the ground, it means that one side of the angle is this, the other side is this horizontal to the ground. It's how much? 36 degrees there. Now, before we solve it, I want everyone to translate this one by using a figure into a piece of paper. It's very important for the start. Fantastic. It's very important for the start. Fantastic, Oscar. Brilliant. So honestly, that's brilliant because it's not easy to find it. It's not easy to draw it. Yes, please do that on a piece of paper. Matthew. Yeah. Write on a piece of paper. And show, highlight what is a balloon, where is Albert, and there is, I should say, Bell. It's very important. This point is going to be the most important point of your life.
That's okay, I mean.
I'm just going to take that. This is balloon. Oh, I love the balloon here.
Albert.
Albert, and this is Bell.
Oh, yeah.
Doesn't mean it's actually normal necessarily, or any angle it can. Oh, that's right. That's a great one. Awesome. Thank you. I love the balloon. It's very inflated, and that's a good thing to start with. Fantastic. Fantastic. In the head of the balloon.
I haven't decided yet. It's the circle so far.
Oh, I love the fancy. That's very good. Try it.
Whoa. I'll be your W, man.
Oh, my friend Daniel, how's it going? We have one more, that's right.
What do you get?
One person. I don't know. And that's the question. How do you know? Fantastic.
No, but you got envision it.
Oh my God, I love it. Spectacular. Now, guys. Now, guys. Now, as we do not have much time today, look at another one point. As we do not have much time today, we just move a little bit fast. And make sure that you take notes. Okay, now, the first scenario that we may come with is this. We say that, okay, this is Albert on the left, this is Bill on the right, and that's the balloon. And you see that, okay, we have, for example, the side, the roof of the Albert, the balloon is, as we said, it's 7.8 meters. And the length of the roof to the balloon from the side of the bell is 5.9 meters. Now, we talked about the angle, which is 36 degrees from the side that the Albert is holding the roof with respect to the ground, which is 36 degrees. And the test that we're looking for is that what is the distance between Albert and Bell for this instance? But remember, that's the thing which we want to understand. That's why I just put the question mark. We just want to see how much is the length of the AB. But guys, remember, we have two scenarios for this. And what you have done, all of you, is this. Everybody just follow the same, huh? But this is only one option because we may have two configurations for it. And that's what it makes it a little bit tricky, and it makes the math a little bit different for this. If all of us at this stage agree that Bill and Albert are two different sides of the balloon, look at that. If this is the balloon, you see Bill and you see Albert on both sides of the balloon. And that's one scenario. Now, I'm just going to go to, I should say, to Zoom and start working on this. But remember, the thing that we just want to do is that to find the length of the AB. Now, let me just put the screen, share the screen. We have this. We have this one side. This is the other side. This is the other side, because I'm just going to represent it just by using a simple geometric shape. We had A, we had B, we had C. How much was it?
36.
That's right. How much was this length?
7.8 meters.
Okay, and how much was this? How much?
5.9 meters.
5.9. And now, guys, the thing that we're looking for is the length of the X, which is the AB. How much is that length? Now, we have some tricks for it right now. We have some tools in order to find the AB. We have learned two laws, the king and the queen of the triangle. Because what is that? For example, Oscar, we look at the triangle, the first thing that we can think, Julia, is that we say that we have two laws. The one is the king and the other one is the queen. Matthew, the first thing which I want to say is that I see that I'm expecting to find the length of, let's say, the AB. Then it reminds me of one thing. It tells me that in order to find the length of the AB, it is it has a twin brother. And the twin brother is the angle which is facing that length. Look at the angle, Lucas. Look at the angle C, which is facing, I should say, you see, it's looking at the length X. Now, the first thing is that in order to be able to use either the king or the queen law, it's always expected that we can have the angle which is associated with the length which is looking at it. Then as a result, if I just want to find the length of AB, what am I expected to find? Yes.
Well, you want to find the angle.
C, that's right. That's right, which is facing it then. Now, in order to find this, I see, wait a minute. How can I find it possibly? As long as what? As long as I have this angle, only one angle, and I do not know the other two angles because I know that in geometry, if I say A plus B plus C becomes how much? That's right. But the problem is that only Kate, I have only one angle, which is angle A, and I do not have any other two angles. But at the same time, I notice that I'm, sorry, what? That's right. Then it means that at the same time, I'm so lucky that I have two lengths. It reminds me of the sine law. What was the sine law? It says that. That's right. Absolutely. Equals to, I say that the sine of the angle, which is A, over the length which it is facing, which is A small, equals what? I need, this ratio is very well understood. Why? Because we say that the angle which we have A, the angle which we have A is 36 degrees. It comes with the length associated with it, which is 5.9 meters. Then this is very good. However, I look at the other side. Look at the angle B. Do I know how much is that?
No, we want to find.
That's right. But if I know how much is that, then I have 36 degrees. That angle, then I can subtract it from 180 to get the angle C. Now, in order to find it, Oscar, what do? I say that I do not know the angle. I called it sine B. However, I know the length associated with it, which is 7 point, how much?
8.
Let me just write here. I write B because then I'm just going to put the numbers there. Now, this is the ratio that we build from the Queen's law. Sorry, it was a king one, sine law. Now, let's put the value there. I have a how much? 36 degrees. I put sine of 36 over the A, which is the length associated with the angle A, which is 5.9. The second ratio, I'm looking for the angle B. I place B there. And then I see that, for example, the length associated with the B, which is looking at the Daniel, is what? Is how much? 7.8, huh? Yes? If you are not using, I should say, the laptop, please close your laptop. Just make sure that you are just using your pen and pencil because it helps you to learn much better. Daniel, please shut it down completely. Completely off, fantastic. Thank you. Now look at this. I'm looking for this, B, and I have the other things. I know that then as a result, the thing which I can say about the angle B is going to be this. It's going to be, I say that the sine B is equal to, I multiply both sides, Sabrina, to 7.8. Then it becomes 7.8 times sine 36 over 5.9. And it gives me what? It gives me the value of the B, which I'm going to find. It's very easy. You put 36, sine 36 in your calculator. How much do you get?
You get 0.5877.
How much?
0.5877.
0. Okay. And now equals to 7.8. Sorry, how much you said?
0.5877.
Okay, let's do this one and 5.9. Then as a result, the value of the B, how much is that? B, use your calculator with this notation, becomes sine inverse of this value. You have learned it last week, huh? Who said no? You really? Oh, it means that, for example, Rodbert, if you have, for example, sine of an angle equals, for example, let's say, for example, 1/2. Then you ask yourself, what is the alpha? What is the angle? You go to your calculator, you just put this. You say alpha equals sine inverse, sine -1. That's on your calculator. And you put this value right in front of it. And the alpha becomes, for example, 30 or 60 or something. Becomes 30 degrees. That makes sense, Radbo? Then it means that we have to have the calculated at that stage, the Oscar, to find it. We say that the sine inverse of this value, 7.8 times 0.587 over 5.9, which roughly it gives us what value?
50.1.
That's right, 51 degrees. Roughly, we do some kind of an estimate. Everyone is okay so far. How did I get the value for B? Everyone, if you know, just raise your hand. Everyone. Means Julia and Sabrina. You are not sure? Rod both. Matthew, Celia, Kate. Everyone is okay? Kate, you didn't understand it? Sorry, what?
No.
Okay, sure. Now, please let me know. If it didn't make sense, please let me know, Kate, I explained.
Not 51, it's 50.1. No, it's not. Closer to 50. Yeah,
Let's-
50.9. Oh, yeah.
Let's keep it rounded to 51. If anything you have taken from 50 to 51, we just get 51 as an estimate. Everyone is okay now then? Yes, fantastic. Now, then I got the value for the B as 51. Then Daniel, the question is that we were looking from the very beginning. No, sorry, if I'm calling your name, I do not mean that you are doing something bad. It means that I just want to, talk to you. You got it, Kate?
Yeah. Thank you.
Awesome. Now I just kind of ask myself, the whole thing that we was planning to do, Sabrina, was that to find the value for the C. And now the value for the C is very easy to find because I know that from the basic geometry method. That's right. That's the Queen law. Fantastic, Kate. Then I say that I was looking for the C to just use, for example, the formula that Kate mentioned, the King law, the Queen law, or the cosine law. But the value of the C is this. I know that in any triangle, the sum of the angle is 180. Then C is going to be how much? 180 minus. How much is value of the A? That's right, 36 plus 51 degrees, which it takes me to the C as how much?
93.
93 degrees. And there we are. Now, we just use only one single ratio. Because what? Because whenever somebody gives us a triangle, we say that, wait a minute, I can use some simple laws to find everything about that angle. I use two ratios to find it. Now, I'm going to go to the next page. I'm going to redraw this. Guys, how much time do we have? 30 minutes. Almost 30 minutes, I think. Okay, I think that's fine. Look at that. It was 36 degrees. It was how much? 51. It is 93. And how much was this one? 7.8. This one was 5.9. That's right. We're looking for this angle. We have two methods now to use. The cosine law that Kate mentioned. Kate said that, okay, if I say that it is A, B, and C. So I'm just going to move a little bit faster, make sure that we are going to be done today. We said that the value for the C squared, which is also the X, Lucas, becomes what? Becomes A squared plus b squared minus 2 times AB times cosine of the angle between this. This is one method. This method says what? Means that C should equal C squared equals to, how much is A squared? 5.9 squared plus how much is, let's say, B squared, which is 7.8 squared minus 2 times 5.9 times 7.8 times cosine of 90 degrees. Then C is going to be the square root of whatever you get. Please do not solve, do not put that in your calculator. I'm just going to use another method, then we match it together. Now, this is one method. This is the method of the cosine. And the value of how much is that going to be, we are going to do the method number 2. 1. Yes, yes, you got it? 9.53. Let's approximate it to 10 meters. Okay, fantastic job. Now, the other thing which I'm going to do is this. I'm going to again use the other method, which is the sine law. Now, it was a cosine method. We call that cosine method because it doesn't matter. They are like the king and queen. They are the royal family. They're always together. They cannot be, one. That's right. Now, the second method that we are just going to talk, the method number 2, is that I use the sine law. Again, I need to have a 1 ratio. Look at this, the one which we have. The angle, which is A. I know everything about this. I know how much is the angle, and I know how much is the length associated with the angle, which is in front of it, Oscar. Then I say the sine of A over the length, which is facing it, which is going to be, let's say, for example, 5.9, equals to what? I'm looking for this length, X or C. I put it C here, but I look at this angle C, which is sine of C. You see? You see what happened? Yeah. With the angle A, I knew everything about this. I knew the length and I knew the angle. Can you please close the door? Somebody please close the door. Thank you, Lucas. Now, then as a result, you see that from this relationship, whatever we have sine of 36 over 5.9 should equal to, we got the C, which is 93 degrees. Thanks, Lucas. Over C that we are looking for. Then the thing which you want to do, Daniel, please close it. No, just watch it from there. Oh, really? Okay. Okay. Now, when we are looking for the C, we said that we're looking for the C. Let's you remember the example of the frying pan that you're making scrambled eggs. You suddenly turn it upside down and everything goes back. Yeah, I'm going to do this one because I'm looking for the C, which is at the denominator. I bring everything up. Then I have 5.9 over sine 36 equals to C, which I'm looking for, at sine 93 degrees. Then you see that if you multiply both sides by the sine 93 degrees, which is at the denominator, because what's the plan? You have to isolate C, that it has no coefficients whatsoever. Then I multiply both sides by sine 93 degrees to isolate C, Oscar. That's right. Then I get C equals to sine 93 degrees multiplies to 5.9 over sine 36 degrees. If you put that in your calculator, how much do you get? That's right, around 10 meters. Because these two methods, as the king and the queen, they do not treat the one triangle differently. Both of them give you the same answer without any exception. Make sense, everyone? Everyone is happy with it?
Just one question.
Yes, please.
Like for the 2AB, after the 2AB, what's the log?
2AB.
The S,
Oh, this one?
the log. Cosine.
Oh, cosine of C.
Okay.
It means that the cosine of the angle between the axes cross.
There's a stronger of the two.
Everyone is doing great. Fantastic. And now, oh, I like the details there. Yeah, great job. Let me see. Oh, I like the colors. Fantastic, guys. Fantastic. Great effort from everybody. I am beyond words in fact. Oh, great. Sabrina, fantastic. Matthew. Let me see everyone. Oh, I like the colors. Fantastic. Fantastic, Daniel. Fantastic. You got it right now. Now, guys, now we are going to the problem. So far, what we have been doing was a little bit, I should say, a kind of a warm-up to get into this problem. We haven't done much yet.
Is there another problem?
They're the same problem. However, the same problem, the thing that we did right now was a kind of a warm-up to get to the next stage. You remember, here we said that when you try to put that in your paper, you said that we all agree, we all had the same thing. That if it is the balloon here, Albert is on the left side and Bill is on the right side. Everyone agrees on it, huh? But there was a second option, which causes a little bit problem. And this is this case. And look at this.
Whoa.
You have the balloon on the right, and both Albert and Bill are on the left. That's the second option. Yes.
Can we do this like in group instead of doing it as a class?
Oh, no, because I have to teach you something now. Yes, sorry, thanks. But of course, tomorrow we have enough time to just work in groups.
All right.
Let me check how much time do we have. But I promise tomorrow we are going to have lots of group work together. We end up by 1:25. Fantastic. We have 25 minutes, and that's good. 1:15.
25 is usually what we are.
Oh, okay. Oh, disappointing for me. Now, guys, look at this one. Now we are going to deal with this. In this the scenario, I'm just going to stop sharing from here. Then everyone take a drawing for this. I'm going to go to the slides, which I'm going to work with now. I'm going to do that on a whiteboard here, and I'm going to redraw the same thing. We have this. We have this.
What language is that?
We had A, we had B, we had C. Then here becomes 5.9 meters. Here is 7.8 meters. And of course, the angle that we measured was how much? Fantastic. 36 degrees now. Now, guys, look at this. Here, they call that the ambiguous case. If you hear that on your test, look, that's what it means. What is with the ambiguous case? Look at this. We have the same scenario. This is Albert, A. I think it was B here. Yes, it was B standing for Bell. This is B standing here. And we have the balloon at point C. We had the length of the ropes, but you see that balloon is on this other side of all of these configurations. Now, look at this. What do I want to do? In the previous case, you remember we said that in order to find the angle C, because it's still the problem that we are going to deal with this is that what is the length of A to B, which I call it C. Still, we are looking for this problem. How much is the C? In the previous case, that what we did, Janaya, we said that in order to find C, I'm looking for the angle associated with it. Kate, guys, quiet. Guys, quiet. I'm gonna send someone to Laura's right now. Who should I send? Now, the thing which I say is this. I say that in order to find the value of the C, what we did before, it was exactly we tried to find what? We tried to find the angle of C. That's what we did before. Well, let's do the same thing here. I say that I'm just going to use the King law or the sine law, and I'm going to use it in that way. I say that I'm looking at the sine A, because I know the angle A, and I know the length associated with it, which is A, equals to what? Because I know the value of the length associated with the angle B, I'm going to use the other angle. I see what can I afford in that problem. And what I do, Chloe, is this. Then I say that the sine B over the length associated with the angle B. Yes? Now, then what do we do here? I'm just going to put the values in there. And Ella, if I put the values in there, I see that for the A, it is 36 degrees. The length associated with it, how much is that, Kate? 5.9. Please close your laptop, please. Thanks. Everyone close the laptop if you are not just following me there. Now, we say what? We say that sine B, which is the thing which we do not know, and I'm looking also for the length associated with that, which is, sorry if I said to close your laptop, because that part is very important and it shows up on your next test. Then please listen very carefully. 7.9. The task is what? The task is again to find the value of the B. If you do this, you see that the sine B, what I do, I have to isolate it elsewhere at one side. Then I see that in order to isolate it, 7.9 at the denominator is very annoying. I have to get rid of this. Sorry, what? Is it? Oh, yes, sorry. 7.8. Thank you. Then I see that. Now, sine B, I multiply both sides by 7.8, which is annoying. Then I get 7.8 multiplies to the right, to the left, sine 36 degrees over 5.9. Now, if you do this, how much do you get for the sine B? Or you can say that sine inverse of B, you get it like that. You get everything here. 7.8 multiplies to sine 36 over 5. No. It's not the same. Now that's the trick. Whoa. And that's the trick that we spent today 1 hour to get to this point. And that's the fruit of today. And that becomes B. And Rodwood, you see what happened there, huh? Look at this, everyone, look at this. We said that ask for everyone, fill me up. We said that the sine B is this expression because we got it from there. In order to find the B itself, on your calculator, put sine inverse and get whatever comes over there over
You
here.
get 50 points, you get the same.
We get the same. How much we get? No, still we are. This is we have some way to go.
Oh.
And look at this. How much do we get? We get 51, roughly 51.
Yes.
51 degrees. But guys, look at this. This is the lesson for today. And that's what they call that. Ella, please listen. Look at here. That's what they call that ambiguous case, Because look at that. We got 51. Everyone listen very carefully. But the 51 is what kind of an angle? Acute angle. 51 is less than 90. 51 is an acute angle. It's less than 90. But the angle that we have here is obtuse, as you said. But it's a contradiction. 51 for an acute angle is a measure of an obtuse angle. Then we say no. 51.
129.
That's right. We say that 51. Fantastic, smart. We say 51 that we got here. Everyone listen. 51 that we got here is for this outside of the triangle that you're solving. But the blue one, Oscar, how much is that? Becomes 180 minus 51. Because the sum of these two, this is a line, and it becomes 180. How much should you get for it? 129. Fantastic. 129. And now that's what they call that ambiguous case. If you see that on your test, or if you're walking outside, you are going to buy an ice cream, somebody has to, is it ambiguous? It has to remind you of this, that you measure the angle for a triangle, but it needs to be acute, but we are looking for an obtuse angle. Then you subtract 180 from it.
That makes sense.
Then do not always trust the thing that you get from the formula. Do not always trust the thing that you get. Always compare this with what? With the problem. In the previous case, because our configuration was that Albert was here, Bill was on the other side, 51 makes sense. But now here, because Albert and Bill are on both sides at the same side, as with respect to the balloon, then we see that 51, yes. Oh no, as long as you see, okay, that's 51. 51 is for this, then I subtract 180 from this, you're totally fine. Everyone is happy now?
Yes.
Yes, fantastic. Now, and my question is that we go back to the same thing. We are still looking for the value of the C. Yes, please do it yourself. But knowing that the angle for C, how much is C, guys, now?
15 degrees.
Because C becomes 180 minus 36 minus 129. Now it becomes around 15. Then guys, look at this. Then the value of the C, because we are looking, Sabrina, for the left associated with it, comes with the C. We have 129 over here. We have 36, and the sum of these two should be 180. Then 180 minus 36 minus 129, it gives me how much? 15 degrees for the C. Yes? Fantastic. Now use one of those cleaning laws to find the value for the C. We finish by 1:15, then it's good. We have 5 minutes. What we had 5.9, we had 7.8, we had C, okay, guys, I'm solving it slowly there. You should see that we have all the information that we needed to find. We have the angle 36, 129, 15 Janaya, 5.9 this length, 7.8 this length. We are looking for C. I say sine A over the length associated with it equals, I look at this, sine 15 associated with C. Then how to solve it? I inverse both sides. 5.9 over sine 36 equals to C over sine 15. Then I'm gonna isolate C. C equals to sine 15 times 5.9 over sine 36, which gives me how much?
2.5. I think 2.59.
Let's get it at 2.6 meters. Because we put sine 15 in the calculator. We put sine 36 in the calculator, and we just simply multiply these two things together, and we get C as equal 2.6 meters.
Perfect.
Now, any questions?
No. Auxiliary.
Yes. Yeah, of course.